In this second task, we're going to be looking at aircraft instruments, the theory and practice. The practice part, you'll be using the instruments in the flight simulator, doing a flight test, and the theoretical part will be in the computer lab and with your own research. And we'll be looking at 6 main instruments. The 6 we're going to be looking at are called the basic 6, and they're in front of each pilot. They consist of these 6 here: the airspeed indicator, indicated on the top left, the attitude indicator in the middle top, and then on the right we've got the altimeter, that's top right. In the bottom left we've got the turn coordinator. In the bottom middle we have the direction indicator, and on the bottom right we have the vertical speed indicator. And we're going to look at these 6 and we're going to find out how they work. So, just to break down the task, aircraft instruments theory and practice. Part 1 will be on Bernoulli's theorem. We'll be looking at the theory behind the operation of the airspeed indicator, which is the one top left, which uses Bernoulli's theorem. And when you do that, you'll be building a small simulation, as shown here. I think we've started that previously. It'll be done in Excel and is described in some other videos. The second task is to look at the basic 6 instruments. For each one, we're going to describe the principle of operation. I draw a simple diagram to show how it works and explain the physics behind how it works. So if we look at the altimeter, the altimeter is number 1 here. No, the altimeter is here, sorry, number 3. The altimeter looks a bit like a clock and displays altitude. Altitude is height, height above sea level, and this is measured by the expansion of contraction of a fixed amount of air acting on a set of springs. As the plane climbs or descends, the relative air pressure outside the aircraft changes, and the altimeter reports the difference between the outside air pressure and the reference contained in a set of airtight bellows. Now, sounds complicated, but if you look at a quick diagram of what's inside an altimeter, it consists of a balloon or a set of metal bellows here, which can expand or contract. So it will contract as the aircraft altitude increases because of the air pressure pushing in on it. Bellows, here we have some pictures of bellows. You can see how they're constructed. This one here is quite good. The bellows in the altimeter is obviously sealed. If we go back to that diagram, you can see the ribs there, and when it expands, it pushes this lever which turns that dial. That's the basic principle of how it works. And when it contracts, it pulls the lever back, which then pulls the needle back. Obviously it's a bit more complicated than this. There's another diagram here which shows the gearing between the lever and the actual needles on the display. But you can see there's no electronics in here at all. It's just a simple metal bellows which pushes the lever and it turns the dials. Now you'll be doing that the same sort of diagram in this sort of form, really, for each of those 6 basic instruments. 1, 2, 3, 4, 5, 6. They're numbered here: 1, 2, 3, 4, 5, 6. So basic principle of how each of them work. So that's the second part here. and then explain the physics behind it. So we'll go on to that a bit later, but we'll have the physics behind, for example, the altimeter, so air density decreasing at altitude, etc. And maybe an equation for it. Now part 3 is using the instruments. This will consist of a flight test on the flight simulator. You'll be taking off from Seattle Airport to a second nearby airport. So here we have the flight simulator is across the corridor in Cookcroft 305. Here's a picture of Trevor sitting in the cockpit. You'll be taking off from Seattle Airport, shown here, and just quickly zoom in on that. It's in the western USA. It's quite a good airport to use because it's got 2 long runways. Now here we are, 2 runways there and there, and you'll probably be landing on this airport here. Called Boeing Field King County International Airport. So that's the last bit. You need to use the instruments, and we're going to be testing how well you can read them. So during you'll need to get a couple of practice flights in to try and get used to the instruments, the 6 basic instruments. Try and get used to how they work. These 6 here. That shows you the airspeed, etc., etc. Right, so there we are. Yep. Trevor then will give you details of the flight test and record your flight for you on a memory stick. So when you go into your actual test, take a memory stick with you, and you'll be given the results in this format here, in just several columns. Time, you'll be giving a measurement every second, airspeed in knots, altitude in feet, direction in degrees, and vertical speed in feet per minute. And then you'll plot those out into a graph that looks something like this. So airspeed against time, altitude against time, direction against time, and vertical speed against time. And we'll be giving you some sort of basic flight criteria. For example, climbing to a certain altitude, in a given direction, and then you may have to change direction, and maintain a constant airspeed throughout the whole flight. The vertical speed will be quite high when you're taking off, climbing to an altitude, and the vertical airspeed should drop to 0 when you're going along at a fixed altitude, and it will only decrease when you come to land. So you'll just plot this out in a similar format to this against time, and that is the whole lot done.